How many different outcomes of winner and runner-up are there in a pie eating contest with 6 people? So in this case, we're specifying order. So order is important. Because we have a winner and a runner-up. And so that means this is going to be a permutation. So when this is a permutation, we have 6 people in the contest, so it's going to be the permutation of 6 choose 2. And this will be 6 factorial over 6 minus 2 factorial, which is equal to 6 times 5, which is equal to 30. Now, you could have gone right to this 6 times 5 because there are 6 possible outcomes for first place. And since once first place has been awarded, there are 5 possible outcomes for second. So the answer is 30. So you can either use the counting principles or the permutation example. Now, a bag of marbles contains 12 solid colors and 8 cat's eyes. If you reach into the bag and withdraw 5 marbles, what is the probability that you will select exactly 1 solid color? Now, here, order is not specified. So this is a combination. And if you withdraw 1 solid and then 4 cat's eyes, that's the same as drawing out 4 cat's eyes and then 1 solid. So the order that you draw them out, withdraw them from the bag is not important. You're just picking out 5 marbles, and we just want to know what the end result is. So the number of ways we can choose 5 marbles out of a bag of 30, because we have 12 and 18, so this is going to be the combination of 30.
Victoria Wimet reports to me. Please ask, please, Victoria Wimet.
So this is equal to the combination of 30 choose 5. And so this is, again, a combination. Now, the number of ways we can draw out 1 solid. Well, we can draw 1 solid 12 choose 1 ways. In other words, since we have 12 solids in the bag and we're going to draw out 1, there's actually 12 ways we can do that. We can draw, so this will be 12. And we have 18 cat's eyes, and since we're drawing out a total of 5, there are 4, we're going to draw out 4 cat's eyes, so this will be the combination of 18 choose 4. Now this is equal to 12, and this makes sense because there are 12 ways we could choose one of these 12 solid colors, times, and the combination of 18 choose 4 is 3,660, which is equal to 36,720. And this combination is going to be 30 factorial over 30 minus 5 factorial times 5 factorial. And that works out to be 142,506. Now we're asked, what is the probability that you will select exactly 1 solid color? So recall that the probability of 1 solid is equal to the number of ways we can choose 1 solid, which we determined over here, divided by the number of ways that we can draw 5 marbles out of a bag of 30 marbles. And that's what we found over here. So this is going to be then 36,000 720 divided by 142,506, and that reduces to equals 680 divided by 2,639. And if you want that as a percentage, so to be 680 and it's about 25.8%. So next, we are asked to calculate the probability that we draw 5 marbles out of the bag and that we get no cat's eyes. In other words, that we get all 5 are solid color. So the number of ways, or the probability that we get no cat's eyes, is equal to the number of ways we can draw no cat's eyes divided by the number of ways we can draw 5 marbles out of a bag of 30. So the number of ways we can draw no cat's eyes is going to be 12, because we have 12 solid colors and we're going to pick all 5 solid. So 12 choose 5 times 18 choose 0, because we're going to get no cat's eyes, all over 30 choose 5, which is the number of ways we can draw 5 marbles out of a bag of 30 when order does not matter. So when we do this, so 18 choose 0 is 1, and the combination of 12 choose 5 is 792. And from above, the number of ways we can draw 5 marbles out of a bag of 30 is 142,506. And this reduces to 44 over 7,917. So now the probability that we draw at least one cat's eyes will be equal to 1 minus the probability that we draw no cat's eyes. So this will be 7,917 over 7,917, subtract 44 over 7,917, and we get 7,873 over 7,917. Now the next question, how many arrangements of the numbers 1 to 6 only once had the 5 and 6 together? Now, so we're only going to use these numbers once. Now, if we're going to have 5 or 6, we could either have 5 first or 6 first. So we're going to block these. So there are going to be a total of 6 digits. And so the number of arrangements will be If we block the 5 and 6 together, it's going to be 5 factorial times, and since 5 and 6 are blocked, there are two factorial ways we could arrange those two digits. So then this is 120 times 2, which is 240.